Normally, traces are drawn using axis-aligned and 45-degree lines. When line refraction is enabled, two line segments are offered from the starting point that was the first click to the current crosshair position, one axis-aligned, one 45-degree. The slash key, or the key sequence MLF, changes refraction, cycling through different options, refraction ordering and X mode. In the X mode, there is no refraction, but a straight line from start to crosshair in 45-degree steps. The all-direction lines mode turns off limiting line slopes to 90 or 45 degrees, and there's always a straight line between start point and crosshair. When rubber band mode is turned off, any portion of a connected trace can be moved separately, breaking the trace. In rubber band mode, the trace segment is moved, but its endpoints remain connected to their original neighbours, whether this needs modification to those neighbours or adding new line segments to the trace. Rubber band mode is indicated with an R in the bottom status line. A middle segment is a line or arc with both ends connected to other lines or arcs. Standard rubber band mode allows moving a middle segment in any direction. When the rubber band keeps middle line DIR option is enabled, the middle segment is constrained to move only orthogonally. This makes it easier to fine-tune complicated traces without accidentally moving segments sideways. At the end of the day, an important metric of board validity is that the gap between two nets is larger than a minimum value. This gap is called clearance. When a trace is drawn within a polygon, this clearance is normally enforced by the polygon code as a visible cutout from the polygon. However, other trace lines are not cut into. Do we have enough clearance between these two vertical line segments? An easy way to figure is to enable visible clearance while routing. This option displays the pen clearance, which is most often coming from the routing style. Assuming the routing style clearance is set up to be equal to or larger than the minimum clearance, the yellowish indication around the predicted line shows the required clearance. Moving the cursor over an existing line gives a visual feedback on whether any other copper object is too close. When routing inside a polygon, the indicated clearance is exactly what is then cut out of the polygon. When drawing in proximity to other objects, the indication helps deciding how close the routing could go. Besides indicating the required clearance, PCB-RND can also enforce it by blocking the trace when it is getting too close to a copper object not connected to the network being drawn, highlighted in green.